Good morning. My name is Martin. I will give a short presentation, not so much because we're a little behind schedule, but my voice only allows me so many words per day at the moment. So I work in our professional services organization, and for the last 6 years I've been working with the Port of Rotterdam, made in Holland, and so I can relate to the talk that Galen just gave. The Port of Rotterdam approached us sort of 6 years ago. We implemented an enterprise GIS for them. They didn't have any GIS before then. They had a person who could make a map and had another person who could make a database query and so on. So we implemented ArcGIS at the port, became their location platform, and we started integrating with all these different business processes. And one of those business processes is around strategic planning. What does the port need to do in the next 10, 15, 25 years to remain a leader in the world in port business and a major hub in Europe? The Port of Rotterdam has been around for centuries, right? It goes back to the 1400s. Before then, there were settlements there. It's a river port, so it's a natural place to enter into the European mainland or to exit with goods from Europe to other places. And what you see is that over the years, especially in the 20th century, there's been a rapid growth of the Port of Rotterdam going into the western direction. Those areas all represent, you might almost say, phases in the world, right? So the oil industry came up at some point, and that is when the Port of Rotterdam started receiving oil, and other goods were being received before then. Ships grew in size over the years, and so the further west you look, the deeper the port is, the wider the waterways are, versus the sort of Middle Ages sized ships, small ships, and inland barges that maybe stay mostly on the eastern side of the port. The Dutch but there's a saying, right? God created Earth, the Dutch created the Netherlands. When the Dutch run out of land, they reclaim it. And the two most western portions of the port, they're called the Maasvlakte, the plain of the Meuse River, if you will. Those two areas have been developed since the 1970s. Actually, the westernmost, the Maasvlakte 2 area, has been put into operations in 2015, right? So it's very recent and it's still under development. Some of these areas actually are not even in use yet. It's still water, right? So this is already showing a little bit of a future picture of the port. What you also notice is the port has only grown in western direction. It cannot grow east, it cannot grow north or south. There's urban areas all around. Right above, north of the port, there is the famous glass houses. If you look at the satellite image, you'll see your light reflected. Well, that's because there's glass houses all over that area. So the only way to go is to go west. And economically, it's at the moment not viable to further expand the physical area of the port westwards, right? The North Sea gets a little deeper, it takes a lot of money to invest, and it's going to take years to develop and create a return on that investment. So this is really the premise of my talk, right? The port can physically no longer grow, but at the same time they are ambitious. The economy is growing, and so they are trying to grow within the physical limits of the port. And it turns out there's actually quite a bit of room for growth there. The port is also a busy port, right? There's a few thousand ships, sea ships come in every day. There's cargo trains coming in and out of the port. There's pipelines with oil and natural gas and other liquid bulks that go to European mainland or come from European mainland. There's actual industry there, and then there's rail. There's a famous, or maybe I should say infamous, rail project in the Netherlands. The Dutch government decided to build a dedicated cargo rail line from the Port of Rotterdam to the Ruhr area, the German sort of industrial complex. And the idea was that would alleviate some of the regular passenger rail infrastructure because cargo would go over this dedicated rail. Problem is, Germany has its own harbor called Hamburg, and of course they want to attract goods and goods flow through Hamburg going to the same mainland areas of Europe. And so the Germans decided not to build the extension of that cargo rail line on the German side of the border. So right before Germany, these cargo trains, they are long and big, and if you go to the canyon here, you'll see them every few hours or so. They go from the dedicated line to the regular rail line. And I have family who lives there, and they basically are saying that all these little towns that have the rails go through them, they're impacted directly by all the cargo trains coming through the port. So this is a key problem, right? So the port is thinking about this. If you grow in volume, it means that all these different transportation modalities will grow in numbers. So what the port has done is create or define a process to do strategic planning. This diagram, it is in Dutch, but some of the words you might pick up. There's a commercial aspect to this, right? One thing is that the port is a landlord, right? So they actually don't operate the terminals; they lease the terminals to Maersk and Shell and ECT and all the different large global terminal operators. So there are contracts with those operators. They're in place. They might last for another 10, 15 years and so on. So that puts a little bit of a limit on what you can do. The port also doesn't really know how efficient those terminals are. How much throughput do you generate from ores per square meter per year? Right? That's a number. So really the only thing that the port can do is look at the overall throughput. There's port dues that these shippers pay to visit the port to offload cargo. Obviously, for a container terminal, there is you know how high the containers are typically stacked, right? So you know more or less the capacity. How many containers could you put in some space, given the fact that you stack them this high and a container has a standardized size and so on, right? So there's a few sort of performance indicators that they can know of. Then the port also looks at the actual physical space, right? So it's not just how high do you stack the containers, but how much of the terminal do you actually use for container storage versus unused terrains, versus roads, versus office buildings, or other types of infrastructure that is taking up space inside that area of the terminal that you might use for more goods storage or otherwise, right? So that's sort of the physical aspect of the port. And they don't just do this on land, they also do this on water. Like I mentioned, this new Maasvlakte area is still in development. Some of the land has not been sort of built yet. Over the last few years, there was the largest construction vessel. It's called the Pioneering Spirit. Think about it as taking two tankers, maybe not the biggest tankers, but taking two reasonable sized tankers, and then essentially putting them next together, welding them together as if it's like a catamaran, but then it's like 300 meters long and 300 meters wide and so on. And this ship is being used to lift oil platforms from the North Sea and put them in other places or lay cables under the oceans and so on. It's the biggest ship in the world. So what the port did is they essentially dredged an area in this new undeveloped land or water so that the ship could moor in that location so that the final construction phase could actually happen. So the port was generating revenue out of water at that point in time, right? So that's the physical space. What do we have available? How many inland barges can we actually handle? And if they need to wait because the sea ship is still unloading, where do they wait, right? Do we have space for those ships to do that? I mentioned the stress on the transportation infrastructure. So that is the yellow box in the middle on the right, where we look at how many trains can you actually have on a rail per day, or how many trucks. The port has Bluetooth sensors around the port on the road infrastructure, so they measure how many trucks pass by on a daily basis. But as I said, it's an urban area, so there's a lot of commuter traffic and other traffic in the area. So congestion is a really, really big problem. There's essentially one major freeway going west-east along the port, and all of that cargo traffic that goes by road has to go over that particular stretch of freeway. So the port is thinking, can we do it differently? Can we maybe use more inland barges versus trucks? They also do this from an environmental perspective. So that's the lower right box. That's the environmental space, as they call it. How much space do we have in the physical, in the transportation, and in the environmental domains? They look at noise pollution. Trust me, you do not want to live next door to a scrap metal terminal, right? Refinery, a little buzzing maybe in the background, that may be okay. But because there is such a large urban development around the port area, noise pollution, safety, right? So chemical plants and so on, there's all sorts of strict zones that need to be applied that essentially put limits on what can the port actually do with the land and the space they have available. So that resulted, the port came to Redlands. They do this every year, and we meet with Jack and others to talk about the plans for the port, right? So we're working together in a 10-year partnership with the port. And they tell us, this is what we want to do. And then we tell them, well, this is what we can do now. And maybe if we change or adapt our roadmap, we can do this other thing also with you. And then we try it out with them, right? So the project itself, I mean, the diagram is an iterative process. There's a little arrow, right? But the project and the program we work with the port is also iterative, right? We learn together and we grow together. So this is, you might say, a very traditional geodesign process, courtesy Jack. He drew this on the whiteboard in the meeting, and I took a picture and then put it on the slide. So I don't claim any credits for this. So understanding the existing condition. Well, this is good, right? Because we implemented ArcGIS there, and we know exactly, and the port has a lot of data management teams, and they have processes in place, so that's good to go. They also had a lot of forecasting models, although they were all in Excel. Nothing against Excel, I use it every day. But the point is that myself, my colleagues, and all the others, we all have our own version of the Excel file. And all those performance indicators, they're all my own version. And it's not an enterprise solution, if you will, right? It's everyone has their own, and I come with an answer, and you come with a different answer, and there's no way to say which one is better or right from the other. But they do have the models. They do understand those different processes. So suitability models, I mentioned about environmental constraints or physical constraints there. You cannot put a chemistry plant next to some other thing, right? Those are all sorts of constraints. And so what they then do is they design these alternatives, and I'll come back to that in a little bit. Right, so, and you see these three words, right? The port is thinking, are we going to remain an oil port or become a terminal, a container port only? What actually is the future of oil, right? So that goes into into scenarios. What if the oil price keeps where it is now, or what if oil actually phases out in 20 years or 30 years? What do we need to do now to be ready then, right? That's the key point here. And then they communicate about this because these are people from different departments in the port, and they come together, they work on these designs, alternatives together, and then they evaluate the results, and they say, okay, well, maybe this area here needs to be a container terminal. Maybe this customer that is on the eastern side, inland city side, maybe if we move them to this other place, it's better for them and for us, and then we can put some other industry in that inland city area. So that's the design process they go through. So they create these alternatives, and they have these, let's say, economic development scenarios. They go through throughput calculation. All of these analyses are driven by the amount of cargo that needs to move through the port. And the physical space, where does it actually go? Where does it happen? And from there, we have a set of impact models. We call them quick scans because they're not meant to be super accurate. They just give you an idea, right? Is it going to fit? Do we have enough berthing locations to handle the inland shipping movements due to the growth in cargo in 2030, in 2040, etc.? There is a scorecard. I'll have an example of that in a little bit. And that feeds back to the design team, and then the design team can decide to make new alternatives. And so, and then on the lower right, you see these expert systems, right? There are other systems that do very detailed analyses. It might even be a traffic analysis system that looks at one intersection, knowing the number of traffic movements on that intersection. Is it going to be busy at 5 o'clock, right? When do you go to the cafe, right? What time do you go to the cafe to avoid the line? It's Thursday, so it's Korean barbecue, so beware, right? So they create these alternatives, do that at the port level. You can see here different industries in different areas, right? Maybe we need to consolidate those. And then they think about this available space, right? This is the physical space aspect. So what land do we have available? Some land is undeveloped, some land is leased. Maybe the lease ends in 5 years, and then we can do something different with it in 5 years. Or maybe we need to move the customer, which has an expense to it, etc. Right? So this land and water balance is a key aspect of what the port does in their designs. They also look at the individual terminals. Right? So here you see an example of a terminal. The yellow areas are called silent reserves. Those are basically unused areas. Right? So what if we put a little more, looks like it's a liquid bulk terminal, right? So you see the oil drums there. Well, we can use that. Or maybe we do something different in that area. Right? So that's the kind of designs they make. They do this in ArcGIS Pro. Right? So from the start of the project, we said, okay, let's do this in Pro. And as we go, obviously, Pro has evolved over the last 2 years, and the system has evolved with it. We have an enterprise database because everyone needs to look at the same data, right? Part of this was essentially a standardization effort of what goods types do we actually recognize? What transportation modalities do we actually have at the port? Because different departments were using different terminologies for that. So in Pro, there's a toolbox, and there's editing tools, right? This is just Pro. So what they do is they create these designs in Pro. We have created some facilitation for that. So they can put a terminal in a place, and they can draw it and say, this is going to be a deep sea container or transshipment or LNG or whatever, right? But they also manage those constraints there. So these are noise levels, decibels, right, that you can generate in some area. All of that is defined for the entire port for these different constraints. And then they run these models. And the output of the models is typically visualized in this dashboard. This is an application that anyone in the port can look at, even if you don't participate in the design process itself. And in this case, it tells you a little bit of what they call a space balance. It tells you how much land do you need versus how much land do you have available. Right? That's how much space available is there, right? This tells you a little bit about what throughput was generated. Because they don't know the details of the individual terminals, they only know how much throughput the terminal generated so many years ago. So the capacity of the terminal, productivity, if you will, is at least that, right? So that's one design aspect that they can look for. Transportation-wise, right? So in this case, we calculate how many meter hours, essentially, you need to allow ships to be in the port for a certain duration during a year, right? When a ship comes in, nowadays there is 18,000 TEUs, container units on these large vessels. It takes them a couple hours to unload and so on. And during that time, that space at the quay, at the dock, is in use. You cannot put another ship there, right? So this gives them an idea. So the dashboard was great, but the port also said, well, we want all these other things, right? We want to learn. And so we started to use ArcGIS Insights to look across alternatives. This is a diagram of 3 different years. And you look at 2 different alternatives, for example. And here you see the same alternative, 2020 versus 2040. Right? So that is a tool that they're using that can connect to the same data as this scorecard does, and gives them a lot of flexibility in doing further analysis, data exploration, what-if scenarios, and so on. So the key point is that the port realized that the way they can grow is by treating information almost as a transportation modality. Right? So this has been one of the key drivers for them for the last couple of years. And it doesn't end here yet. Right? So what you see here is on the left side, this is the bar under the dashboard. There is a timeline. Right? So what is what we have implemented over the last few years with the port in setting up an ArcGIS environment. Recently, the port has implemented an IoT environment where they have real-time sensors that look at the information in the port, water levels, wind, etc. And then PortOptimizer fits all the way at the far end of the spectrum. In doing forecasting and strategic planning. The port is developing a plan for a digital twin, and we are working with them, where you essentially take those long-term decision-making processes and shrink them down into something that allows you to do decision support over the next hour, over the next day, over the next week, because that is going to drive further optimization of the port. A ship comes in, it's in the Strait of Calais, slow down because you come in at low tide at this speed, and you're too deep. And if you wait a little bit, the tide is going to rise. You can come in at a high tide, and you're good to go. And so maybe a typical Dutch way of growing then is if you run out of land, right? You just go to a different dimension, right? You go to time, or you go to other optimizations. All right. Thank you very much.